Hi there, Rachel Sherman here, and this is the second part to the video about working through the project for my students. But if you're not one of my students, then you might want to use this video to help learn how to use the bin functions in Excel, and then also creating histograms slash bar graphs and circle graphs. So what you'll notice is we've already gone ahead and brought our data over from our raw data page. And to save some time here, I've gone through and made a list of different things that are going to be useful to us. So behind the scenes, you may want to pause if you're following along with your own project and then fill in these things. So N is just how many pieces of data you have. Your max and min, you can use, you'll see the max function and the min function. That's optional. You could also just go through the list and figure out what they are on your own. The number of classes is 6, which this is something that you're going to use that 2 to the k rule for, just to determine how many classes would be appropriate for your data. If you're not sure about that, go ahead and look for another stat video to help teach you how to determine the number of class intervals that's appropriate. And then your width, of course, comes from the max minus min divided by whatever the number of classes are. So you'll see here we've gone ahead and taken max minus min, divide that by k number of classes. And being that we ended up with a class width of our data set, so this is physical inactivity in adults, I've gone and rounded that up to just a whole number to keep things a little bit simpler. So what you're going to do, and this is how the bin functions work, is in order to use the bin functions, bins can be set up where the bin that's written represents the upper bound of the interval that you'd like. So take a look at your data for a moment. We have a minimum of 16.4, so it might be useful to start our lowest interval at 16, just to keep it as simple as possible. You could start at 16.4, I'm just trying to avoid having too many decimals. Since we're using a class width of 3, I'm going to count up by 3 to get all of my lower bounds, and then just take a smidge step backwards to get your upper bounds. And whatever those upper bounds are, those are representing your actual bins that we're going to use to calculate this. So you'll see that anything we do here when we're using the frequency and bin functions, the first interval will contain all of the data from 16 up to 18.9, the second from 19 to 21.9, and so on and so forth. And what you want to make sure of is that your minimum and your maximum contain the min and the max of your actual data set. Now, once you go ahead and get this set up, you're going to come over to your column, let's call it a frequency list. So what this is going to do is allow you to set up a frequency distribution, and then that frequency distribution can be used for graphing. In order to use the frequency and bin functions, you're going to highlight a list that matches your bins. So remember, the bins should contain everything from that lower bound all the way to the upper. And this is what we're going to base our data off of. So now up here in your box, you're going to type equals frequency. And you'll see if you double click on it, it tells you take the data array, which is our list of 51 pieces of data, and the bin array. So I'm going to start by highlighting all 51 pieces of data, comma, go ahead and highlight your bin values. You're going to close up parentheses. Now what this is doing, if you're not very familiar with how Excel works, when you set up something and you highlight multiple cells, it's forcing it into what's called an array. The array is basically locking those values in place, knowing that they're dependent on some other set. So it's going to return numbers for everything in that list, as you can see here when we hit enter. You'll also notice that at the end it added an extra. If that number is not 0, it means that your widths were not wide enough and that you're missing something. So the last thing I would say before you move on is go ahead and do a quick tally. You can do this by adding this list up. If you've done this correctly, it should be equal to your sample size. So if I take a quick sum, you'll see that the total is 51, which matches our sample size, which should make sense. It means we've covered all of our bases. So now what we're going to do is, in order to go ahead and graph these things, I'm going to try and simplify this a little bit by creating a list of just interval values, and then we're going to pop it up top there. So I'm going to call this maybe my class intervals of physical inactivity, U.S. adults 2019 per 100. Okay. And then next to that, I'm going to have my frequency. So the frequencies, we're just taking what we had here. We're going to paste those values over so we don't have to worry about the array anymore. And then the class intervals, try and clean it up the best you can. So this is from 16 to 18.9. Then we have from 19 to 21.9, and so on and so forth. So I'm going to pause and go ahead and finish filling this in. All right, so now that we've gone ahead and simplified our distribution a little bit, we're going to learn how to use this to go ahead and do our graphing. You're going to start by highlighting your data. So highlight both columns, including the headers. And we're not going to necessarily go about this the formal way that Excel can construct a histogram with bins, because you may have decided, if your data is simple enough, just to go ahead and type this up independently. So I'm going to show you the simplest way to do this. If you go to Insert, and then come over here where you have something that looks like a bar graph, just do a little bit of hovering and take a look at which one looks most appropriate for your data. Either of these first two options will probably work. So I'm just going to start with this one and see what happens. Now, as you know from taking a stats course, any good graph should contain a title, axis labels, and if there's any other information, it should be labeled as clearly as possible, or anything else that's needed. So there's a few ways to go about turning this into a histogram. Now remember, a histogram also needs to have the bars pushed together. This data is continuous. You're talking about physical inactivity. If you scaled this up even like per 1,000, then the first one would be 307 adults per 1,000. It's continuous in some ways, but also it's discrete data in others. So for something like this, since we've grouped it up, you should be setting this up using histogram, which means make sure that your bars connect. So a couple of options that you have is you can come up here to Quick Layout, and you'll see that there is one that looks almost exactly like what we're after, right? It's got some axis titles that pop in, and it has a header. We're just going to have to change the names. If instead you prefer to do this manually and you want to push the bars together, if you double click, you'll see that there's something that comes up called gap width. You would set that to 0. So the choice is yours, whatever works for you. Since we have this under Quick Layout, I'm going to select that for the easiest option. Now, as said before, any good graph should have axis labels that adequately describe what's going on and a title. So this title represents what exactly? It represents the physical inactivity, specifically groupings of physical inactivity by the physically inactive per 100. So 2019 U.S. physical inactivity in adults, and then make sure down here you label that as the intervals of adults per 100. And then on the side, we're going to label this the frequency. So this is how often that occurs. So when you look at this chart, you can see that, okay, well, it looks like there are 18 states that have 22 to 24.9 physically inactive adults per 100 adults, right? Now, you can also apply those same techniques to creating a circle graph. To do that, just like we did before, you're going to highlight your data, come up to Insert, and click the one that looks like a circle. This doesn't have to be pretty, it doesn't have to be fancy. You can make it as simple or complicated as you'd like. And the one thing that I would always recommend adding to a circle graph is the proportions. So if you have a quick layout function, you'll probably find it over there. So maybe something like this one. So this way we can just see at very quick glance what's happening there. Now, do remember that circle graphs are a little bit different, and they actually provide you the relative frequency of occurrence. So these are the relative frequencies of, in this case, 2019 U.S. physical inactivity in adults. It might not be the most short and sweet title, but the title should be as descriptive as possible to get the point across. Now, to finish out this page, definitely make sure you fill in the box over here that asks for some observations. What does the shape of the distribution look like? Are there any outliers, at least according to what you can see now? Do you have clusters of data? So you'll notice that the data set we've collected for this demo is, I would argue, pretty close to approximately normal, maybe a teeny tiny bit skewed by something over here. And you can see that it's just a little tiny bit off-centered from approximately normal. So I would argue that the data is close to normal, close to normally distributed, but there might be an outlier. Now, it's possible that you went into this project thinking the set of data you collected was going to be approximately normal, but then in actual practice, you find that maybe it does the total opposite, or maybe it's skewed to the left or to the right. So definitely make sure you take a few moments here and make some observations about your data. This should counterbalance the observations that you made before you went and organized your data here. Thanks for watching this video. The next video we get into is going to teach you how to use random sampling to move forward in this project.